In the last video, we talked about the slope of the secant line and how the tangent line is just the limit of the secant line towards a point, which is what we have up here, the definition of what the slope of the tangent line is. So we're looking at the original function at x minus the function evaluated at some value a, and we're taking the limit as x approaches that a. And all over x minus a. But if you look at the bottom, if we plug in a for that, a minus a is going to be 0. So that's where we're going to use our limits from the previous chapter to try to solve for that. We'll use the different tricks that we used back then. The guy below here, that's the traditional form of what a derivative is. So only instead of using a, we use x. But at any rate, the questions for your homework involved using 3.3, which is the above formula anyway. So let's ignore this. And our first one, we should talk about this notation f prime. So f prime of x, this means the derivative of f of x. And f prime at a, this means the derivative of f of x evaluated at a. And that a is the point A. All right. So this number 21, we're given a linear function. We're looking for the slope of that linear function at the point a equals -1. Well, as we discussed before, we already know the answer to this. The slope is going to be 5. However, we still want to use equation 3.3 to solve for this. So the slope of the tangent is equal to limit as x approaches -1 of our function of x, so 5x plus 4, that's our function of x, minus f of a. Well, f of a is going to be equal to 5 times 5 plus 4. And we want x minus a. So x minus a -1 is x plus 1. Okay. So we keep the limit. We're going to keep this limit notation there until we actually evaluate the limit. So don't lose that until you're doing it. All right, so we have 5x in the numerator. We have a 4 here, and we're looking to subtract. Looks like 25 plus 4 is 29. So that's 5x minus 25. Excuse me. All right, so we've got a problem here. So this a is -1, not 5. So we're going to multiply this 5 by -1. So that means we still have this 4, but instead here we have a -5 and a 4, which is -1, which means we add 1 because of this negative here. So this is 5x plus 5 over x plus 1, not minus 1. Okay. And now we're at a point again, if we put this -1 in, write this a little better. we plug in -1, this goes to 0 over 0. So we've got a situation where we're going to multiply this, or actually we don't have to. We can factor out a 5. So let's see what happens when we do that. And I'm going to put that in parentheses. We can then cross these out. And so we just have the limit as x approaches -1 of the constant function 5, and the limit of a constant function is the same, so that's 5. And that's how we're going to solve these, hopefully without the mistakes. Let's see if we can do a little better on 25. This is the other function that we did before. We're evaluating this at a equals 4, so we're taking a square root like we did in the previous video. So limit as x approaches 4. And we're looking at, so our function is just root x. And then we're subtracting the function evaluated at a. So that's going to be root 4. And then x minus a, or x is x minus 4. And again, what happens if we put in 4 there? We're going to get this to be 0 over 0. So we've got some work to do here. So let's do this. And that's at root 4 is 2. So this is root x minus 2 over x minus 4. But we're sitting with a square root. If we multiply by the conjugate, that should get us clear that up. And again, we're not going to distribute the denominator. So we're going to multiply this by 1, which is going to be root x plus 2 over root x plus 2. We're allowed to multiply by 1. X plus 2 is, root x plus 2 is the conjugate of root x minus 2. So this equals a limit as x approaches 4. It's x minus 4 over x minus 4. And then this root x plus 2 stays there. So now, as we did in the previous question, we get to cancel that. We're left with a 1 in the numerator, not a 0. Be careful. 1 over root x plus 2. And when we plug in the 4, that's 1 over 4. So that's going to be the slope of our tangent line at the point a equals 4 for the square root of x.